Okay, we are going to do a lecture over college algebra. We are going to do chapter 1 here. So let's look at this. Okay. This is chapter 1. We have equations and inequalities. Okay, so we will start out with showing the Cartesian coordinate plane. Here is the Cartesian coordinate plane right here. And we have certain points. For example, if we have a point 4, 5, okay, where does this exist in? Quadrant 1. If we have a point -2, 1, where does that exist in? Oh, that exists in quadrant 2. Then we have some other point. So we have -5, we have -3. And where does this exist? Oh, this is quadrant 3. And then last but not least, if we have something like this, 2 and 4, this is going to be in quadrant 4. Okay. So when you have an x value paired with a y value, what you end up getting is an ordered pair. Okay, and this can be, x is always the first one, y is the second one. With any function, you can always take the function and then you can do something called point plotting. Okay, so how does point plotting work? Well, you pick some points and you put them into the input of the function, which is x, and then out spits the output, which is y. So for example, I could do something like this. If I didn't know what this looks like, I could do something like this. I could say x equals 1, and then I can compute this and say, okay, this is 1 squared, and then this is 3. And so now I have this ordered pair, which is 1, 3. Okay, and with this, I can do this over and over and over with many of these x's, and then get a whole bunch of points, and then you can graph it. Okay, let's look here. Maybe I might do something like this. Yeah, I'll do this. Okay. So here's another concept, okay? Another concept here. We have this guy, absolute value. Very interesting right here. We have x and then -x. So it's x if x is bigger than or equal to 0, and then negative if x is less than 0. Okay? And what this function looks like is it looks like something like this. So we have something like this, we have something like this, and this is absolute value. Another thing that absolute value does is it can take any function, okay? So maybe something like this. It will take the negative part of this and make it positive. So it'll flip the negative up and make it positive. If you ever wanted to graph something like this, x plus 1 absolute value, all this would do is just basically raise the graph up just a tiny little bit right here. Still the absolute value. Okay, what about intercepts? Okay, what about intercepts here? What if I have something like this? What if I have a line going through here? Isn't this 2 intercepts? What if I do something like this? Isn't this 1 intercept? What about something like this? I think that's another intercept. Right there. And let's do some more of these. What if I did something like this? What if I did absolute value? And I did this and this. Is that okay? That's okay. So there's 2 intercepts right there. You can also maybe fit one more in. And we can do something like this. Okay, so those are some intercepts of some graphs. Okay, let's talk about some other stuff. Okay, so let's see here. What if I did something like this? Okay, what if I had some graph that was kind of down here like this? Well, there's no x-intercept. Okay. And what if I did something like this? So there's no y-intercept. And then what if we had something like this? What if we just had a circle over here? Well, there's no intercept, no x or y intercept at all. What if we did something like this? So kind of a zigzag kind of thing here. So there's an intercept here, intercept here, intercept here. So we got 3. We have 3 intercepts on that one. And let's see here. And what if you had just a parabola like this? No, there's just one. Just one intercept. Okay. So what if we wanted to graph some things? Okay. What if we wanted to graph some of these functions? Okay. So let's look. So 13, this is in chapter 1. So graph. What if we did something like this? Wouldn't it look something like that? And another one. So we have y equals x minus 2. Okay. And it looks something like this. And what if I had something like this? That's also 2, right? And then I can also have something like this. Okay, that just goes through it one time, right there. You can also have other functions that look like this. So these are some functions right here. You can have other functions that do things like this. You can have a W. You can have a sideways U like this. And you can have a parabola that looks like this. Okay, great. Okay, and now for some word problems. Okay, so what if I say this? A y value that is what? 4 more than twice the x value. Okay, so how would we write that? Well, we could do something like this. Twice the x value plus 4. Okay, great. This is number 47. And then for 48, we can do something like this. The y value, okay, is the difference between 4 and twice the x value. Okay, so what would that look like? I think it would look something like this. So 4 minus 2x. Okay, so what do you guys think? Okay, then we have some other neat stuff right here. Okay. So this is number 75. X times y bigger than 0. And in which quadrants is this true? Okay, so this is really interesting because we're saying it's true here and here. But can we actually show it? Can we actually show this? So, I mean, we can pick some values. So what if I pick -3 and then I pick 2? Is that bigger than 0? I mean, no, that's not. Okay, so that's false. So we're not going to use those. What if I said -3 and -2 bigger than 0? So that's 6 bigger than 0. Okay. Is that true? Yes. Now, where did the -3 and -2 come from? Well, I think they came from this one right here. Okay. -3 and -2. And if you want to look at this one over here, we could pick 3 and 2 and see if that's also true. So if we plug those into here, we have 3 and we have 2 and it's bigger than 0 and this is true. So these are the two regions right here. Very, very interesting. Okay, actually, I don't like that. There we go. Okay, so very kind of neat and interesting how we do that. Let's see if we can do another one here. So this is 76. And this is y over x is less than 0. Okay, and this apparently is true for 2 and 4. So let's check this out. How about, okay, so 2 and 4. So 2 and 4 are these guys. So let's pick some coordinates over here. So let's pick -3, 2. Okay, and see what happens. So if I put in a 2 and a -3, well, this is true. Great. And then what if I did something over here, like I did a 3 and a -2? So if I did that, what would I get? I would get -2 over 3, less than 0. This is also true. Okay? So no matter what, this thing is true, and this thing is true for the quadrants 2 and 4. Okay, so now this one is very tricky right here. Let's see about this one. So x cubed bigger than 0 and y cubed less than 0. Okay, so this apparently is true for quadrant 4. Okay, so let's see here. Is this true for quadrant 4? Well, what we can do is we can pick like a number 3, -1. That's in quadrant 4. And then we can start using it over here in these equations and seeing if it's true. So this would be 8 bigger than 0. And this would be -1. And this is less than 0. So this is more, this is less. This is going to be the true region right here. And then over here, we have this. We have x is bigger than, or x cubed is less than 0. And we also have y cubed is bigger than 0. So where is this going to be true? It turns out it's going to be true in quadrant 2. Right here. And let's look here. Is that true? So let's see here. -2, 1. Okay, if we plug these in, does it work? So this is the x, this is the y. If I plug in the x in here, is this less? Yeah, because it's 8, -8. And then over here, is this more? Yes, it's more. Okay, so that's how that works. It's actually a little tricky how to do that, but that's how you do it. Okay, this is section 1.2. All right, what if I did something like this? What is this? This is linear right here. Okay, great. So this is a linear equation, but also can also have something that's linear like this. Okay, where you basically have an equation and you just have one variable. Okay, so a and b are constants. So this is 4x plus 12 is equal to 0. Okay, and if you want to solve this, you get 4x is equal to -12 divided by 4 divided by 4, -3. Okay, and there you go. So if you ever want to solve a linear equation, you just kind of do it like this, okay? So isolate the variable x, okay, move everything over. All right, great. What do we have here? 14 divided by 2, and we get what? We get 7. Okay, great. Let's do another one. What if we have this? 4x plus 5, okay? And that's equal to 29. Okay, well, all we have to do is do something like this. So this is 4x, and this is equal to 24. And then we can divide here. All right. And what do we get? Is that what we get? I put it down wrong in my notes. Okay, so I believe the answer is 6. Okay. Oops, I just saved over the last one, I think. Yeah, I did. Can I undo that? Let me see if I can undo that. I don't know. Oh no, here. Can we undo this? I don't know. I don't think we can. So anyway. Okay. Well, anyway, let's keep on doing some more. Okay, so here's a couple of examples. We have 3 x minus 7, and then we have 5x minus 11. Okay, so this is 3x minus 21 minus 5x plus 11. And we can add these together, and we can say negative 5 plus 3 is negative 2x. And we can add these together to make, I believe, 10. Okay, so there's another example right there. And here's another example to work out. So this is example 2 in the book. So this is 2x minus 3 minus 17 is equal to 13 minus 3 x plus 2. Okay, well, this is going to be 2x minus 6 minus 17 is equal to 13 minus 3x minus 6. The minus 6's go away. And 2x minus 17 is equal to 13 minus 3x. I can add the 3x over. We have 5x minus 17 is equal to 13. I can then add the 17 over. Okay, so then we can get 5x is equal to, what's 13 plus 17? And I think that's going to be 30. And then we get x is equal to what? 6. So there we go. Okay, now over here we have another example. Okay, so this example is like this. Okay, so how do we do this? We have this right here, okay? This is going to be negative x plus 1 over 3. And we simply find some type of common denominator. LCD and we multiply everything by it. So let's see here. I think the number is 12. So this is going to be 3 times x plus 2. Okay. Then it's going to be 4, negative 4x plus 4. And then also 24. Okay. Well, let's see what we can get over here. So we have 3x plus 6 minus 4x plus 4 is equal to 24. And let's see what we can do here. Okay, so we can put these guys together. Okay, this becomes negative x. This becomes plus 10. And we have this. Okay, so let's see here. Am I doing this right? So this becomes what? 14. Okay, and then with the negative, it's now negative 14. There we go. Okay, so example 4, we have this 1 over x, then we have this 1 over 5 plus 3 over 2x. So how do you do this? Well, there's a couple different ways, okay? A couple different ways on how to do this. Sometimes the best thing to do is just to multiply by the LCD. So the 10x there. So this is 10x over x is equal to 10x over 5 plus 30. Yeah, well, let's just do this. 3 times 10x over 2x. Okay, so this becomes 10. This becomes 2x. And let's see what this becomes. This becomes what? This is 30 divided by 2, so this is 15, right? Okay, great. So minus 15, minus 15. Okay, and so what we have is we have negative 5 is equal to 2x divided by 2 divided by 2. And now we have this. X is negative 5 over 2. So, kind of an interesting problem there. And I think the last one we have is this. So let's see here. Let's see. Yeah, we need to start a new one for this one. Okay, let's start a new one. Okay, so this is example 5. Okay, so we have x over x minus 3 is equal to 3 over x minus 3. And this is plus, this is 9x minus 3 over x minus 3. Okay. All right, wonderful. Let's see what we can do here. I think I remember what I did. I think I just moved these over. Yeah, I did something like this where x minus 3 over x minus 3. I subtracted this one over, and then we get this. And you can't really divide these out. Okay, but you can do something like this. So let's see what we get. We get what, 9x minus 27? Is that what I got? I think I got that, yeah. Okay. So let's just move the left-hand side over to the right-hand side. So we have 0 is equal to what? 9 minus 1 is what? 8x, okay? Negative 27 plus this would be what? Negative 24, okay? And then you can divide by 8 on both of these, okay? And so what you end up getting is you end up getting x is equal to 3. However, if you look right here, we have a restriction where x cannot equal 3. Okay, so I think that's it. No, I think I have one more. Yeah. Okay, I got one. Okay, so here's one more. So this is 2x plus 1, okay? And this equals 2x plus 3, okay? Well, let's look at this, okay? So this is 2x plus 2 is equal to 2x plus 3, okay? So we end up getting something like this, which is not true. So this is no solution, okay? So no solution on this one right here. And yeah, well, no, I think they got more. Let's see here. Oh, yeah. This one's interesting. Okay, so we'll do this one. So we have 7x plus 9, okay, is equal to 9 times x plus 1 minus 2x. So we have 7x plus 9 is equal to 9x plus 9 minus 2x. So let's see what's going to happen. The 9's are going to go away. 7x is equal to 9x minus 2. We have, let's see here. We have 7 and 9, so we have 2x. And this is also 2x. So what happens if they are both the same? So you know what you're going to get? You're going to get this guy right here, identity. So that is how you do that one. Okay, I think I'm going to end here. Okay. But I wanted to at least make some type of video about this section. So anyway, so I will hopefully upload this, but yeah, here are the lecture notes. And this is for College Algebra Chapter 1. Anyway, that's it for today. So let's see here. Recording.